2.5 minutes. Live, everyone. Okay, you can start.
Hello, everyone. I am Blanca Antizar, European Director of Consultancy at Arroyo Utilities, and I will be the moderator today for this special session, ILTAC, Model to Support Water and Sanitation Utilities to Adopt Innovative Technologies. I am delighted and honored to be here today to talk to you, and welcome everybody here today. Our session will start with a welcome by Marcello Basani on behalf of the Interamerican Development Bank, who is exploring the opportunity that TAC provides to support innovation among water and sanitation utilities. Then I will provide you with an overview of ILE and our technology approval group model, followed by the presentations of 4 technologies that have been selected because of their innovative approach and impact on the water sector so far, and for the suitability and opportunity they represent to support utilities to overcome the challenges they face. I would like to introduce Marcello Basani, Senior Water and Sanitation Specialist at the Interamerican Development Bank. Please, Marcello, the floor is yours.
Thank you, Blanca. Thank you very much. From the Interamerican Development Bank, I would like just to take 5 minutes to talk a little bit about innovation and why it's important this event today. Nowadays, about 165 million people in the Latin American region do not have access to safe water, and 440 million do not have access to safe sanitation. They estimate that to reach all the population with a safe service would require about 14 billion per year up to 2030. And I would like to stress this figure because it's really mind-blowing. $14 billion per year up to 2030, which is significantly higher than what governments are investing at the moment. On the other hand, we cannot rely on business as usual. Actually, we estimate that doing things business as usual, we would take 100 years to get to 100% of the population. This means that we have to do things faster, more economically, more efficiently. In other words, we need to innovate. We've been working on this for the last 2 years at the IDB, and actually we ran a diagnosis, an assessment. We did an assessment to understand what are the main barriers to innovation. Certainly, there are some legal and institutional barriers. For example, regulation has been focused mainly on guaranteeing the human rights to water up to now, without thinking necessarily out of the box. And also there is a lack of culture for innovation in the sector. But we believe that possibly the great obstacles here is the lack of connection within the ecosystem. There's no coordination between startups and utilities. There is no dialogue, and that's why today's event is so important, and that's why the work that Arroyo Utilities does is so important. Isle utilities offer this space of interaction between the world of R&D and innovation and utilities. So before giving you back the word, I would like to stress three main messages. The first one is certainly the importance of technologies to generate innovation, to spark innovation. We already see the application of a lot of technology in the sector, artificial intelligence, machine learning, big data, etc. The second message is that technology per se is not necessarily the solution. Innovation technologies need to be complemented and accompanied by social and organizational innovation. And this is very important for us. And third, and this is very important, we need to foment this cultural change. We need to change the culture of the sector so that it opens up to innovation. At the IDB, we've been working on this a lot. We will be working more, and actually next year we will launch a facility for innovation with resources that will be used to rightly do so. Foment this and consolidate this ecosystem, foment experimentation, creativity, trial and error, and also give the opportunity to startups to develop, incubate, and accelerate solutions within the utility world. So thank you very much to Isle Utilities. Good luck and enjoy this workshop.
Thank you very much, Marcello. And now we will continue the session with a presentation by myself. I would like to provide with all of you with an overview of Isle, who we are and what we do, and focus on our technology approval group model, which plays a very important global role to accelerate the adoption of technology and innovation in the municipal and industrial water sectors, and also provides this ideal forum for a dialogue that Marcello was highlighting a minute ago. So we are an independent and global technology and innovation consultancy that brings together technology and commercial specialists to facilitate relationships. We were founded in 2010 and the headquarters of the company are in London, UK. We are a global team of scientists, engineers, business and regulatory experts, many of whom have postgraduate degrees. Our common drive is to make a positive social, economical and environmental impact through the development and adoption of innovative technologies and related practices. We are driven by curiosity and collaboration and care about making the world a better place for everyone. We are focused on the water sector and provide independent advice on innovation and technology, supporting utilities, technology developers and investors. We use the extensive and diverse consulting expertise of our team to identify technology, deal flow, undertake due diligence, provide market intelligence, and work with investors, connecting technologies and facilitating collaborative approach to share best practice globally. Our services include the Technology Approval Group, which is a global innovation forum for technology end users. At the group meetings, utilities watch pre-voted technology pitches and have the opportunity to discuss their merits with other utilities. Certainly, it is a dialogue. Shortly, I will provide with more details about the TAC model. We also provide a wide range of consultancy services, from research consultancy to due diligence to feasibility and evaluation studies, and also more strategic pieces of work for a variety of clients that include utilities, technology companies, investors, or multilateral organizations. We also have several online tools, which are subscription-based services that enable end users to access specific information which is not readily available elsewhere. We have a global innovation network that cannot be replicated by others, with offices in Europe, Australia, Middle East, Southeast Asia and North America, and also presence in Latin America and Africa. Al has been running the Technology Approval Group, or TAC, since 2010, first in the UK, and then in Australia, USA, Europe, and South Africa. We have over 250 water utilities globally, and we have run those events with them. Over that period, since 2010, I have reviewed over 10,000 technologies and delivered more than 275 TAC events globally. This provides IL with an unprecedented access to the global access market and the related technologies. Here now, I would like to provide an overview with a selected number of members of our global innovation ecosystem and TAC, which includes over 250 utilities globally, also industrial end users, investors, and multilateral organizations, such as the IDB. I would like to highlight during the Brazil Water Week that our members in Brazil include also IGEA, IWA, BRK, SABES, PAPCON, SINTCOM, and we hope to work with many more very soon. We believe that the adoption of technology and innovation will make the world a better place. So what is TAC and what is the TAC model? TAC is a global innovation forum of the world's leading water utilities. We undertake due diligence of the technologies presented at the TAC meetings and coach them through the process. TAC provides a great opportunity to technology companies to gain market exposure to end users and investors. TAC accelerates the market uptake of innovative technologies by engaging the industry end users and investors during the commercial stages of development.
Senhora Blanca.
It is
Senhora
important.
Blanca, sorry, Blanca, just a second. Can you please share your screen because we cannot see it. Can you share your presentation? We've not been able to see it.
Apologies for that. I thought you said that you could see it. Can you see it?
Ok, ok. Opa,
Okay,
havia compartilhado e caiu.
it was being shared and now it got disconnected.
Can you see it?
Now, yes, we can see it.
You can see it now. Okay, perfect. Yeah, so it is important to mention that TAC introduces pre-commercialization to early commercialization technologies with technologies with TRLs between 6 to 8 to end users to speed up the process of getting these solutions validated and commercialized. This is the point in the commercialization timeline when seed funding dries up after the research and development phase and when the cost to bring these technologies to market is highest. TAC is one mechanism for bridging the gap between those resources that exist at the early development stages and those that exist at the later commercialization stages. So how does TAC work? IL conducts an annual technology needs assessment with each TAC member to understand what the top priorities are and what are the challenges the utilities face. In parallel, our global deal flow team undertakes a global search to identify qualified solutions to address their priorities and challenges and undertakes a commercial and technical due diligence to the solutions identified. Prior to TAC, members review a list of emerging solutions and select their top 5. At the TAC event, our TAC members review solutions with other utilities. The TAC format consists of 15 minutes presentation of the technology, 10 minutes presentation of questions and answers and discussion with the presenters, followed by another 15 minutes discussion between the utilities and review of the technologies and the merits of those technologies presented. We collect all the feedback of all the discussions and undertake a SWOT analysis that is shared with all the participants and technology developers. Following each TAC event, if there is any interest, IL will support the next steps between the technology developer and the utility. All the technologies that are presented at TAC are available online at our technology database to all our TAC members. To date, we have an online database with more than 1,300 technologies that have presented at TAC. And for each technology, we include the technology presentation, information on case studies, and the feedback shared by the utilities during the TAC event. So this is our TAC model. But before I finish this presentation, I would like to present a few members of our dedicated team to support the water sector in Latin America. And of course, we will be delighted to work with you shortly. So thank you very much for your attention so far, and apologies that I've noticed that you didn't see my slides during my presentation. And now, to follow with the agenda, we'll move to the presentations of the 4 selected technologies. So I would like to start with the presentation given by Riventa and Free Flow and Mr. André Vizioli, and also Mr. Steve Barrett will present this first technology.
Thank you very much. So, yeah, my name is Steve Barrett, and I'd just like to say a few words to introduce Riventa and André Vizioli, who is our local partner in Brazil, who's a general manager of Aqua Technologies. So my name is Steve Barrett. I'm the managing director of Riventa. We are based in the UK. So Aqua Technologies is our gold partner in Brazil, and we've been working together for a number of years. So as I said, Riventa is based in the UK. We were established in 2006, and we've delivered over 250 projects in 10 countries. We have an office in South Korea and an office in the USA. And we're growing through good quality partners who have good relationships with utilities and industrial clients in a number of countries around the world. We are constantly innovating, and to do that, that needs investment. And we are very pleased to have recently, at the end of 2019, to have gained investment through SOAR SAS. SOAR is, I think, the 14th largest privately owned utility in the world, and they're a great partner for us, and because they, not just as an investor, but they're also a client. So they give us perspective that is otherwise difficult to appreciate, and they also give us a very large marketplace to test our products internally. And so that's been a very successful collaboration, and with a $1.5 billion annual revenue, it's a good stable partner to have as an investor. So that's what I want to say. Riventa is very pleased to be operating in Brazil, and very grateful to André, who's going to deliver a presentation in Portuguese. So over to you, André. Thank you.
Thank you, Steve. Thank you very much. Bom, como Steve mesmo.
As Steve himself introduced, I'm the general manager of Aqua. We have a partnership with Riventa we have had for a few years. The technology has been in Brazil for 3 years, and we have been advancing among our main clients. I'll give you an overview on the technology. We have 20 minutes, so we will just give you an overview so you can understand what are the benefits we can provide in operation and the type of reduction we can offer. The first slide you see on your screen is a slide showing an overview of what we can provide. We work in 2 fronts and 2 layers, so to speak, in water operation. We work with reductions that we say that are low tax operations, reductions in operations themselves, where there's not a lot of capex to reduce energy costs and pumping and startup. And then we can also show gains by means of optimizing the maintenance, and this involves a little more capex. And Usually our experience is between 15 and 10% with OPEX and 10 to 20% when there's an investment. But our experience shows that what happens here in Brazil is very different from what happens in Europe due to the way maintenance is conducted in different parts of the world. So where are we today? We can act in rotating equipment, among them the pump with pumps, but we can also work with submergible pumps, turbines, tractors. We have experience with that in Brazil, including a 3000 HP blower. But our great benefit is the level of uncertainty that our test has. We have a lot of accuracy. We can be very certain, we are very confident in what we are delivering. I can tell clients that after I measured, I'm 99% sure what has been done. This is very helpful in decision making. I'll show all slides. This is the main challenge we face. A major portion of our clients that are already familiar with this world of hydraulics and energy are in a struggle because we know that 90% of the cost, the largest cost of any water operation here in Brazil is power, electrical power. When it's not 95%, it's 70%. Then the main consumer is usually a pump. We know the pump are the main users of it, power. So what do we do? From our experience, we know that our clients know that how much they're paying. They go into the free market, they try to reduce the rates they're paying, and they have mastery on that. When we go one level beyond that and think about the stations, it's a different level when you're thinking about stations and plants. And due to energy metering, we don't know if we're measuring the wastewater treatment plant or the pumping plant, so you are not quite certain of the power consumption. And if I go up on yet another level, and I can make a comment, how much is the pump, in fact, consuming in terms of power? How efficient is it? And usually, we don't get an easy answer from it. This is due to the great challenge that is measuring this pump in operation. This is the main challenge. A pump, when it is purchased, its cost is almost 4%. The operating cost of a pump in terms of energy is 88% throughout its life, with maintenance to operation. But when someone asks what is the cost to operate a pump, it's very hard for a client to answer. And we go after that point. We can indeed show you with great precision what is the cost that you have with that specific pump, which is 95% of your energy consumption, and you can make a decision with more accuracy. You have the right to have your decisions made with a lot more confidence. So the result of all of these variables that are kind of obscure in our daily operations is to individually assess the high pressure pumps, the water pumps, because the benefit is reducing the consumption of power. We have several types of measurement. We use the conventional method, which is provided by all pump manufacturers. They measure power, they measure the flow, the height, the nanometric height, and these are measurable variables, and the others are constants. Here, this is done in a controlled environment. It's easy to do. They have a mastery on it. Doing this in the field is not as easy due to issues of accuracy. The accuracy you need to get, and you go to the operating side. You have to turn off the pumps because you need a single piece of data in terms of flow. This makes it so difficult that clients are not trying to do it. It's so complex. You bring together 3, 4 teams to get it together. You need to measure it in operation. You need to make the test available. You need to reduce supply, and this might make it unfeasible. Our experience shows that clients do not perform this type of analysis. And it's so important, since it's very important in terms of power consumption. And we know that pumps represent a large portion of the energy. So what would you do? We can be fast to the level that the market requires. You need to be fast to be able to act based on it. And you need to be able to analyze, see the profile. So that's why we are with ISLE, to show that there was no technology with the accuracy that we offer. We look at these tests using the thermodynamic methodology, and as we use this method, we can be quite fast and quite precise, quite accurate, and very competitive. We can do it in hours with a single worker, a single professional. I will not go too deep into the formulas, but you can contact me for our mechanical engineers, for people who like this calculations. We measure the difference in temperature and pressure, and here I have a variable, which is the specific heat, and I can get to this yield. If I had this variable calculated by the traditional method, with temperature and pressure with the differential, you can ask me, okay, all right, André, but what is the flow? I need to know the flow rate. That's the great challenge. We install everything in parallel, the power meter. This is easy to do in field. It's quite accurate. We measure the motor yield. I'm measuring the pressure to get to the yield. It's the same with the pump head. It's calculated by the software. And then I calculate the flow. So I'm measuring yield to calculate the flow. So what is the result? We see pumps that are with a lot of wear and tear, that have very low yields, under 40%. We've measured hundreds of pumps in our experience. It's that pumps are operating at 60 to 70% yield. They could reach 85%. We have raised the banner with Riventa to talk to manufacturers and to maintenance companies. We are moving forward with this idea. And we started also to find out that as a result, they are very strong. They can operate it, even they're operating out of their range, and they still work. But now we can identify that, in fact, there is a wear and tear, or that it's out of its range. This green curve is a curve we use to measurement. The black curve is the manufacturer's reference. And you see on the right side an inverter pump without wear and tear, but operating out of its range, showing that this is also inefficient. This is our range of products. We have a portable meter for predictive measurement to check pumps individually. We have the temporary meter. We can measure all pumps, and we can analyze the curve for the system, and also do analysis to optimize the plant. We can get a larger data cloud in a few weeks, and we can work to optimize it, which usually what seems simple in our heads might not be quite that simple to fix. There's lots of variables. A common computer can do it, but our head can't calculate this. We cannot do this that easily. If the client wants, they can also have a fixed hardware on their facility, and to demand even less from our clients, all of the information is sent to the cloud, a cloud owned by Riventa and operated by it, and you have access to that data online. So we have 2020 vision to reduce 20% of the electric bill from a water company. So this is the view we have, and this is how we like to work. This is how we like to look. We focus 20% in the larger pumps with a goal of 20% reduction in the costs for power. As I mentioned, we focus on OPEX, which are operating implementations, getting the pumps to have the best performance possible, alternating their mode of operation, and showing it so it is easier for the operator to be sure of what they're doing, that they're doing the optimal. And in a second moment, with investment capex, we start remodeling the pumps, replacing them or rebuilding them. In general, our methodology is identifying pumps that need to be refurbished. We provide power savings, and we maximize the durability of the asset by using preventative maintenance. So we can, this is something that goes by if we're not measuring. When we measure, we not only reduce the use of power, we also can have more maintenance of the asset. So how do we install it? It is quite simple. We install them in hours in 4 or 5 water pumps. Both the temperature probe, the probe that you can see here horizontally, and the pressure probe, everything has wireless communication. This can be a fixed or temporary, and the client will have the data in hands with a analysis made by Riventa. So what are the primary measures? Temperature difference, fluid temperature, suction pressure, delivery pressure, and energy input. What is the data you will get in real time? You can get the hydraulic yield individually from each pump, which is the great trick to get that on the operating pump. This is how we can save on maintenance. The power of each pump, of each motor, the flow rate, and the pump head. This is a portable installation, so this does not require them to have the measurement. The client we can take them, we can install the probes. I take it to a data logger. This data logger it concentrates data, but it sends also to the cloud, so we can start working on our servers. Here's a picture of a fixed installation, or as real as possible. The probes on the water pumps, the radios with the measurements, and you can have that either on your station or on the cloud with the Hidronet software, everything by Riventa, and you would have a login and password to get all the information, and also when it comes to the operation of these stations. A few more details. We have tapping on a valve. There's no cables. We are quite flexible with the installation as well. This is a very brief video I'd like to show, and so any questions, this is a power meter installed in the panel with a radio communication. This meter is sending information to the data logger, as I mentioned. I'll just skip ahead a little bit so you can take a look at the equipment. You can see how simple it is. Here is the installed equipment, radio, the probes, as I showed in the picture. The setup is really easy, really simple. But why should you do this? The idea is to identify what you see here. Here on the left, I wanted to show the pumps. They are not in an optimal operating range. We try to get the pump to remain on that range, the optimum range. And what our measurement identifies is these green curves. We can see that they are not operating at a single point. So I'm showing on the left are the ranges they can have when they go beyond the optimal point, or the point that is being specified here. It is inefficient. This is our measurement. We can notice that this pump a lot of the time is outside its optimum range. This is the consequence of one pump. When I look to the whole system, I have a mass of data that we could use. This is a graph in kilowatts per kilowatts hour per cubic meter. So when we start optimizing and using this, I can drastically reduce the pumping costs. So all this green mass will be closer to the yellow portion. Here I have another example as well, which is an example from Sabesp, very similar to what you're seeing here. I'll go a little bit deeper into this detail, but I'll be quite brief. And we have on the y-axis here, we have the kilowatt per square meter per flow rate. You see that the client here in this case could operate in the red range, and it's operating in the, you could operate in the red or the purple. That's what we identified there, with an increase of 12%.
The operational cost, 22% in the capex.
Yeah, excuse me, André. I had to do that, but you have only another couple of minutes.
Ok,
Thank you.
So, aqui, na verdade, o que a gente está mostrando aqui é muito parecido com
Matter of fact, overshoot is very similar to that graph I showed you earlier from Sabesp, and that's from or at France, or in France, you can see specific numbers by flow, and then you go from work that was done by us, 21% in energy savings, very similar to what we did here, except that it was operational over there, not on capex. So it's a little bit more over the system. You can have it fixed, like I mentioned, it's structure, and it can be turned on like that, and you can plan, man it, monitor, and then you launch a report, and that can really solve a lot of your energy consumption problems. So I'd like to thank you. I know I went over my time, but thank you, Blanca, for being kind enough to give me 2 more minutes. That's what I wanted to share. Here is our contact info, and if it's possible, just get in touch with us.
Fantastic presentation, and you have kept very well with the time. No worries about that. So thank you, André and Steve. Yes, before we move in with the next speaker, I would like to ask you a couple of questions, just to that I think that they will be interesting also for the water utilities that are listening to us. The first one will be about how do I decide which pump station I should be working on? And the other one, if you could tell us very briefly about the software, how does the HydroNet software work? Thank you.
You want to talk, Steve? Eu acho que travou para o Steve a imagem.
Yeah,
I think got frozen for Steve.
It is, yeah, now he's moving, so my.
You want to answer, Steve?
You're muted, Steve. If you
Yeah,
can please unmute. Thank you.
Yeah, so André, yeah, if you'd like to answer the first question, I'll take the second one. Would that work?
Bom, sobre a seleção, né, dos
When it comes to the selection of the sets, how do we choose that? And power is an important factor. The power of these motor pumps, they are very important. The energy cost is also very important in the proposal. And of course, you have to look into the complexity level versus the number of pumps. And it's typically a station with the potential for gaining more. So you're talking about 3 or 4 pumps operating in parallel, of course, with a high power level. And that's how we like to work.
So if I can answer the second question, how does the HydroNet software work? So basically, we're receiving high quality asset level data to the cloud in real time. And so our servers can do real-time computation to look at the optimum combination of pumps that are required to meet demand at least cost. So it's always about safety. Meeting demand is the priority, and then cost saving is the second objective. But what we can do is take into account the system curve and measuring the system that the pump is operating in, and we can take into account the tariff as well. So we're able to optimize cost and hydraulic efficiency and ensure that the utility meets demand of its customers, which is really important.
Okay, very clear and very brief answers. So thank you very much both. Great presentation. So I would like now to move to the next presentation by Robin Bell, Chief Operating Officer at Inflowmatix. So please, Robin, whenever you are ready, we can see already your screen. So please, the floor is yours. Thank you.
Okay, good afternoon, and I'm hoping you can hear me okay. Thank you for the opportunity to present today. I'm very excited to show the capabilities we have and the new technologies we're launching to the market. I'll talk principally about our high frequency pressure measurement and the advanced analytics. And I'll talk about a metric we have, which is unique in the industry, called cumulative pressure induced stress. So as a company, we were founded 5 years ago. So and we were a spin out from Imperial College. Our founder, Ivan Stoyanov, is still very much a part of the business and contributes a great deal in terms of the patents. And we have continued intellectual property flow through that relationship. We've grown our client base in the UK, but also around the world. And we have significant penetration in a number of key accounts. We've sold over 3,000 systems to date, and we have a number of key strategic partnerships. One of those partnerships is Suez, who are a minority investor in the company Inflowmatix, which again gives us the opportunity to sell into a large corporation, a bit like the Riventa presentation previously with Sarah, but also with the investment that allows us to do a great deal more and to grow quicker. We have around 26 people in the team across UK and EU. We're mostly a remote company, so there's been a limited impact of the COVID crisis on our ability to progress. And we've tripled our growth in the last 3 years, in fact. And our cloud-based data modeling and analytics underpins everything we do. So if we look at worldwide, and particularly with working with Suez, they have ordered over 800, in fact, closer to 1,000 devices now, deployed in more than 10 countries. And we started the relationship over a number of years, actually going back to 2017, but introduced more broadly as actually the cornerstone of the cost reduction program within Suez. So we're very pleased to be a core part of that, and touching many territories, including Brazil and other areas. So you can see the penetration there, but also in the UK, we have a number of key clients. Anglian Water has the biggest estate of our devices and our analytical software, Yorkshire Water, United Utilities, some of those big utilities across the UK. So our products and services, I'll talk a little bit more about InflowSys Edge. This is our pressure measurement device. It's sampling at high frequencies. We also have, in conjunction with Suez as part of our partnership, a calm network solution. We also work with Cathala on advanced pressure management techniques, and working with Black & Veatch on what we call a DMA health index. So this is a zonal health index, geared initially for the UK, but could be applied broader. And a platform, a product that I won't talk about really today, but Arboricity is a platform which provides the analytical solutions which power the computing, the analytics we do across the board. But also we have an Arboricity service-based platform, which is fairly new, but we don't have time today to discuss that in any detail. So what is Inflowmatix Edge? So it's a low-cost, high-resolution, very accurate pressure measurement device. We're measuring pressures at 128 samples per second, and I'll show that in more detail shortly. These are distributed in distribution systems in 1 to 2 mile spacing, and in trunk systems in around 3 mile spacing. They're very fast and easy to deploy. There's no peripheral equipment, no additional equipment is required to deploy the devices. So it takes less than 5 minutes to go through a sequence to get these connected to the water network. Why do we call it Edge? So the Edge provides intelligent, autonomous analytics. So the analytical solutions are on the device, and this differentiates somewhat from the competition. What we wanted to do was to have that capability close to the edge of the network rather than relying on our cloud-based solutions. So this gives us some advantage in speed of response and reacting to situations that occur in the network. As I already mentioned, we have this cloud-based application to give these insights via what we call a network narrative. And you can see just a couple of quick screenshots on the right from our application. So moving on, some sort of indications of what we do: event alert reporting. This gives some instant feedback on what is happening in the network. Managing those events is very important, because what we believe very strongly in is providing outcomes to our customers, not providing lists of thousands upon thousands of alerts, which really get ignored. So it's very important to give good management. We integrate into corporate systems at whatever resolution a company requires. So this means that rather than as a scale up occurs, rather than relying on our systems, then the company can use their own systems to bring the information from this and other attributes into play. So we're very skilled at doing those integrations, and we've done very many over the last, particularly in the last 2 years. One thing that is really important is the secure communications. You can read the slide there, but in terms of the way we encrypt the data, the way we use the data in what is actually the Amazon Web Services cloud platform is very, very, very carefully structured. Now, the most important part of what we do here is measuring at this very high frequency. So you can see here a plot which shows in blue typical 15-minute aggregated data, which is provided as telemetry into many customer systems. What we provide is the red information, which is sampled at 128 samples per second. And you can see a huge variation, a huge difference in the performance. So I've shown this in PSI. Similarly, in meters of water, this is around 120, I think 120 meters of, no, sorry, 70 meters of water. But those are lost with standard telemetry. Also, just using 1 sample per second data provides some information, but actually you need the full resolution by oversampling at 128 samples to reconstruct a waveform. And this could be a typical pump surge type effect that can easily be created and needs to be seen to be understood and corrected. So we have this metric CPIS, and I'll come on to define this in a little bit more detail. However, in doing burst correlations, typically customers around the world, water utilities around the world have used age, material, climate, and soil information to feed into those burst correlations. More recently, pressure, mean and maximum pressure have been used in those assessments, those models. What we bring is dynamic pressure variations in this metric called cumulative pressure-induced stress, which is a way of us accumulating the pressure information into a useful metric which indicates performance on the network. Now, we did a very extensive trial with Severn Trent Water over quite a period of over a year. We did around 700 deployments of devices for maybe 2 weeks, 3 weeks to gather information about the network. And we were able to very simply correlate the cumulative pressure-induced stress in PSI, shown in this plot, against the burst rate, again here shown as per 100 miles per year. So what was very interesting for us, we showed a correlation between the high volatility in the pressure domain in the network with burst records from over a 10-year period. So it shows that although water systems change, the correlations remain in terms of those high pressure dynamics. So it's a very important element of understanding how water networks are performing. Obviously, we're trying to drive those down, and you can achieve orders of magnitude improvements. So just a quick illustration before I go into some case studies. What are we doing that's different? We're gaining insight from analytical solutions. What we believe fundamentally is network hydraulics are the key to understanding how to resolve problems. We don't rely on just artificial intelligence. This isn't about lots of data sets. This is about the right data sets to get the right outcomes. We continue to work closely with Imperial College, one of the top 10 universities in the world. And we have a number of strategic partnerships, as I've mentioned already. Suez has a minority interest in Inflowmatix, and we collaborate on these calm network solutions across what is a significant network for them, over 200,000 miles, 300,000 kilometers. So I'll talk about some of our use cases here. I showed this plot before of Severn Trent, and we did some pump calming activity with them, and we showed some huge benefits. I've shown these in millions of dollars as an equivalent to the UK pound, and this was presented to the board of Severn Trent, and they saw the benefits and continued the rollout of our technology. Now here is an interesting illustration of pump calming. Now I should say that the calming that can be achieved in the network can relate to many different assets. So it could be a valve operations, or it could be a pump operation. And you'll see from actually the next presentation by Andrew talks, he will show how those valve operations can be controlled. So where we've worked together with various partners, including including Smart Valve, then we can show that we can improve the situation dramatically. So this illustration shows the pump calming, and the before result of a 100 PSI variation was reduced down to a 20 PSI variation after the calming effect. Now this was working very closely with Severn Trent in terms of their pump calming initiative, in terms of the pump control. I'll show another quick case study where we work with Portsmouth Water, showing some preventive measures that can be achieved. Here we were able to show pressure breaches against an expected set of thresholds. and we also learned these thresholds to show anomalous behavior. Now, we were able to detect this. Unfortunately, they weren't able to, in this instance, they hadn't put in the measures to react. But actually, the reaction within 4 or 5 hours could have prevented a number of bursts. This was feeding a large PRV, which was critical to continued supply of a large part of their network. So this was critically important. So by identifying these dynamic activities, we can prevent genuine failures in the network. We have another case study here with Yorkshire Water where this cumulative pressure...
Temos outro estudo de caso aqui.
I'm sorry, was that a question?
Sorry, no.
Oh, okay. I'll continue. So here we show...
I will use, Robin, apologies. I will use this interruption to remind you that you have 5 minutes left.
Okay, I'm pretty good on time, I think.
Thank you.
So this illustration shows where we were able to show in the network the onset of high cumulative induced stress. And just as a reminder, and this shows 220 PSI variations in the network over a 24-hour period. And this is an accumulation of smaller variations or some large variations in the dynamic activity. So the network was working fine, and then at a certain point, this cumulative pressure-induced stress was seen to increase dramatically. We were able to work with Yorkshire Water to identify the zone where this was happening in the north of England. We were then able to use the accurate time stamping we have to localize this down to a particular street. And it was identified as pressure reducing valve hammering and hunting. This was resolved, but actually it wasn't fully resolved because looking very, very carefully at variations in the network using this high frequency, you can see that there are still under that magnifying glass there variations which need to be mitigated. But the major issue was actually resolved here. We have another case study here. Again, I'll just show this quickly, where by implementing in conjunction with Clayval, putting in a control curve, we were able to achieve calmer operation from the network, which again wasn't seen beforehand and could be achieved by multiple devices in the network, giving a robust feedback in terms of the volatility in the network and then using that information to apply a control curve. So I don't have time to show this testimonial, but there is, maybe we can circulate these slides afterwards, but there is a testimonial from Suez here. And we also have a case study, which if I'll try and demonstrate this. You may hear the sound. If this doesn't work, I'll abort. But in fact, it doesn't work in this particular case. But actually, maybe I can try again. Here we go. So this shows a pump operation, and the pump will kick in a few seconds' time. You heard it turn off there. It was particularly noisy. And I'll just move this on a little bit. So the pump is about to kick in, and you visually you see the vibrations. It's probably difficult to pick up on the video, but you hear a phenomenal effect of pump surge. So these are the kind of things to mitigate. And you can also see the build-up of the pressure variations in the high-frequency domain. And unfortunately, you don't hear it in the full volume. If you were actually there in person, it's a huge impact. So it gives an indication, a true indication of how these pressure variations cause physical impact on the network, which damages assets. So my last slide really, I've tried to demonstrate in the short time we have how dynamic pressure variations damage assets. We know that CPIS is a unique metric, which is the first step towards resolution. It involves intervention, but it provides the information to do that intervention. And we have those abilities to calm networks, working with Suez, working with Clayval, and working with other partners. What we like to do is to collaborate with the customer to understand problems they have, so we can solve these with a focused discussion. And we have an ability to sell what we call starter kits to get deployment underway with our customers and initiate the first stage of engagement to really understand how we can help resolve those problems in the network. So thank you very much. My contact details are there if you wish to get in touch with me, and thank you for the time today. And hopefully there are some questions.
Well, thank you, Robin. Very interesting presentation, and I'm sure that people will contact you and ask you questions about this starter kit to start exploring your technology. I have here a question for you. You have mentioned a few times the CPIS metric and correlations with, for example, bus correlations and so on. Why is this metric so important to understand the state of the water networks?
So, so CPIS is the way we've configured CPIS. It does more than just give this basic characteristic, this basic metric. We're working on processes where this can be extrapolated across the network to give an indication of where the network is most vulnerable. Now, coupled with other covariates about the network, where there's perhaps parts of the network which have pipes which are deteriorating, which are aging. Maybe there are criticalities around the supply to certain critical customers, whether it's industries or groups of residential areas. This CPIS gives information which just wasn't understood. So where we're working closely with Suez in particular is using that with these other covariates to deploy in such a way that the network can be understood and then calmed. So we find it's an incredibly useful way of just determining the vulnerability of assets. Okay.
Yeah, fantastic. Thank you very much for your nice explanation. We are going now to continue with our next speaker, Andrew talks, and the smart valves presentation. Andrew, please, whenever you're ready.
Thank you very much. Thanks for that, Blanca, and thank you for the introduction. And welcome everybody to my presentation on smart valves. So my name is Andrew Talks. I'm one of the directors of Smart Valve based over here in the UK. So I'll give you a little bit of background about our company and Smart Valve and why we came up with this innovation for the market. So we have been developing our solution since 2016, but we launched our solution commercially in the UK in 2019. So there was a 3-year development period there where we were investing time and effort into developing our solution, not just for the UK water industry, but to have a look at the global water industry and see if our solution would actually fit into solving a global problem, which I'll come on and talk about in a short while. So the markets we currently serve are here in the UK, we're into Europe, Australia and New Zealand, and we're currently targeting markets in both North and South America. So to date, we're currently installed in Anglian Water, and Robin just spoke about Anglian Water. They are our local water company here, while I'm based in the UK, and they really helped us shape our innovation and shape our solution over about a 2-year period. So we took our initial proof of concept to Anglian Water. They provided us with some resources. And later on in my presentation, you'll see a video of us trialing the proof of concept to see if we actually had an idea that was of benefit and could really drive some efficiencies in the process and the solution that we're putting into place. We've just recently sold into Severn Trent Water after an extensive trial with them. And we've just finished trials at Thames Water, which is another large water company here in the UK, and both Southwest Water as well. So overseas, we also have trials ongoing at the moment with Unity Water and the Arroyo Valley Water in Australia. And in the last week, we've just started a new trial with City West Water in New Zealand. So we can see from a fairly quick start in 2019 that our global reach has extended quite quickly, and we're really pleased to think that we have a solution that is actually going to fit a problem that's shared across water utilities across the world. So everything you're going to see, and I'm going to talk about all of the intellectual property and the code has been created in-house by our very small team, and we've had no external investment in our product to date. So what's our solution? I'm here starting talking about our business, but what is the solution? So Robin quite eloquently, and we know Robin's company, Inflowmatix, fantastic company with some great solutions. We've known them for a number of years. They are there detecting pressure in a water network. And Robin indicated that that pressure can be caused by a number of things. He talked about pump surge, but here we have come up with a solution to try and eliminate transient pressure waves, or water hammer, as it's called, by ineffective manual valve operations. So on a day-to-day basis across the globe, water networks are managed and monitored and maintained using manual valve operations. So that's people out in the field turning valves, opening and closing them to manage the network, to keep the water flowing and to keep the consumers' taps running. But those operations, if they're done ineffectively, they can lead to difficulties in the network. These pressure waves can often be caused by the ineffective operation of a valve, whether that's opening a valve or closing of a valve. And over time, as Robin again alluded to, this constant pressure, the flow of pressure down the pipes, can lead to leaks and bursts and a general degradation of the underground asset. So here in the UK, there is a huge push on leakage reduction. The regulator, Ofwat, has asked all water utilities to try and reduce their leakage by up to 25%. In the UK, there are 3,000 million litres of water wasted every day through leaks and bursts. And that's putting pressure even in the UK, where, believe you me, it rains quite a lot. There is still some pressure on our water systems. And in 10, 20, 30 years' time, water scarcity is a big issue that we're all going to have to face on a global scale. So the more we can look to tackle leakage and the more we can try and identify those causes that lead to leakage, then the better we're going to be managing our network. So this idea of having a calm network is something that's very prevalent in the UK. Now, the UK technicians are all trained on what they call transient rigs. So they've invested hundreds of thousands of pounds, most of the big water companies, in creating a water network that's above ground. And they train their technicians on the opening and closing effect of the valve and how to do it effectively as to stop water hammer being introduced into the system. Now, things like pressure loggers, the high frequency pressure loggers that Robin provides, they will pick up those pressure fluctuations and they're effectively reporting them back to the business. So we're trying to stop those. We're trying to help the technicians turn valves effectively and iron out that root cause. Now, when we created Smart Valve, there was no known solution to fully monitor and manage all these valve operations, and that's why we truly believe we've come up with an innovative product. Indeed, we have global patents in application for improvements in the manual valve turn process on both a fluid and gas network, and that's going really well for us as well. So what does our solution actually consist of? So we've created an app, and you can see on the picture there, the app sitting on the top of a standard manual valve key, which fits on top of the valve, which is then turned to operate the valve to open and close it. So to that app, we can deliver a payload of instructions to the operator that tells them exactly which valve to operate and how to operate that valve. What two workers in the turn of a particular way, turn it, and the returns that we make appropriate to the valve itself. Questions, or if they're doing reactive work out in the field, they can simply set up the operations themselves on the device really quickly, operate the valve, but that data, that telemetry data on how that valve is being operated is immediately accessible via our cloud. Every valve movement, everyone that's been. So it's really important that that speed of efficiency in turning the valve is monitored and corrected at the time that that valve is being turned. So although this is an IT project, although this is an app and a web application, the innovation we've actually come up with is operational. It's about changing the way that valves are operated. It's about ensuring that the technicians who are taking these valve turns out in the field have as much information as they possibly need, are really effective and efficient at turning valves, and we can give them with the data they need at their fingertips in a simple, really easy to use format to enable them to do the job to their ability.
Yeah, I'm not sure whether it is only me who is not hearing Andrew. No. Yeah, we could hear you very clearly, but at one point, Andrew, we stopped hearing you. So you cannot hear me either. Okay. Yeah, so let's wait a few seconds to see if Andrew can sort this out. Apologies for that.
Blanca, can you hear me now? Can you?
Yeah, loud and clear.
Better if you can hear me. Okay,
It is the line is breaking a little bit though. I'm not so sure why.
Okay, can you hear me okay now though, Blanca? Is that okay?
Yes, yeah, it's perfect.
Okay,
Thank
super. Sorry about that, everyone. The joys of doing a presentation across the.
Yeah, it has been only a few seconds, so don't
So,
worry too much about it.
Right. Okay, no problem at all. So we're talking about how we support the technicians out in the field. So we are about operational improvements. This is a people project. It's not really about the technology. We're using technology to make changes and to record the data and provide new data points, the journey through doing the operations for the technicians. So at the moment, Smart Valve is a unique product. We have no known competitive products in the market, and I talked about having that patent pending for the improvement in the technical process of turning a manual valve. So we support all the process.
Sorry, Andrew. Sorry, Andrew, to interrupt you now. I'm not sure whether you want to show us your slides. We don't see your slides right now.
Oh, sorry. Okay.
So if you can upload them again.
1 second. Yeah, I will do that. Just bear with me.
Okay, thank you.
Okay. Hopefully they're there for you now, yes?
They are there. Thank you. Perfect.
Okay, super. Sorry about that. They must have taken the slides down as well. So yes, so we're about supporting the technicians in the field. We manually upload all of the valves in the first instance from the utilities GIS system. But in time, obviously, as they implement our technology, then we do live integrations through APIs with other line of business applications such as GIS and works management systems, SAP or Oracle. So we have a fully integrated workflow for getting the jobs out to the technicians, the recording of that information and the updating of the information in the GIS system as well. So clearly the advantages of using our product is if we can ensure every single valve turn is done to a CALM network standard, we are going to be able to show a measurable reduction in the number of leaks and bursts and water discoloration and water quality incidents on the network. We're also able to update the asset data at source, so we can add more information through the app about the assets. We can see all of the operations in real time coming through to our web application, and the water company knows the status of every single one of its valves on the network. It also helps with avoiding mistakes. So many times at night, the teams here in the UK will go out and they'll do a main shutdown. So they may go out and may shut down 10 valves. And it has been known that when they come off shift and some of the guys go and turn those valves on again, they may only open 8 of them. And then everyone stood there scratching their head, wondering why they have 1,000 houses off water, or some alarms are going off somewhere and something is not right on the network. The smart valve doesn't let you do that. If you set up those valve operations in smart valve, 10 shuts has to equal 10 opens as well. And our alerts within the app will alert both the operatives and the network control center that there are 2 valves left shut here. We know exactly where they are. We know exactly what time they should have been opened, and we can rectify it immediately before there seem to be problems. So that's one of the other core benefits in terms of understanding how valves are operated, sometimes in really difficult circumstances, you know, when they're reacting to a job or a burst or a problem, you know, mistakes can be made. Smart valve will help avoid some of those mistakes. So I'm hopefully going to play a video now on this screen. And I'm sorry, the noise is quite high, so I'll just let it play. So that video there showed me on the transient rig with smart valve in one of the early stages. And that actually was a good example of not following the guidance on the device. So the guidance was there and it was ignored by the technician on that stage, because this is a closed environment on their transient rig, as you saw. And you saw as it went over to the pressure monitor, you could see the big spike in pressure, similar to the ones that Robin was showing there. So this is the effect of closing down a valve too quickly. And our smart valve system was saying, hey, you're going too fast. I'm beeping, I'm flashing at you, I'm telling you you're going too fast. It was ignored for effect just to show the results. So that's what happens in the real world if these valves are turned in effectively. So here's another example. Here's some data that we took from our early trials with Anglian water. So we can turn what we call our monitoring off, so our COM network monitoring off, and we gave the smart valve to the technicians, and these technicians have been working for Anglian water for a number of years, very experienced. And their COM network training would say, well, you turn the valve at 80% of the time at one speed, and the critical part, which is usually the closed part or the open part, at a much lower speed. That's how they've been trained. So we gave them smart valve and told them to record their valve. And this was the profile that we got back for the first few operations from one particular experienced technician. Now you can see there's no potential drop-off there in terms of the turns. So we should see turns at one speed and then a drop-off to a much slower speed as they come to complete that close operation. So then we turned the guidance on smart valve and recorded their activity. So this is with smart valve telling them how to turn the valve. So you've got to keep under that yellow line. So 40 revolutions per minute for the first 80% of the turn, and then much slower, 5 revolutions per minute for the last part of the turn. Now at this profile speed, through Anglian's tests on the transient rig, the water hammer rig, would say, right, we don't create a pressure spike in the ideal environment. If we turn valves like this, we don't create a pressure spike in the system. So with our guidance on, it changed the behaviors of the technician. They followed the rules that were set by the business. So we left them with that for a few weeks and let them turn their valves with our guidance, and then we took it off again. And these are the results that we got back. So you can see, without our guidance now, they positively changed their behavior. We reinforced that calm network profile training within that user, and they started turning valves the way that they have been trained to turn valves. Smart valve's not there to catch technicians out though. Smart valve is there to reinforce their training. It's to support them, because if I was doing turns like this and I did these turns effectively, and then tomorrow where I'd operated that valve, there was a 40-meter column of water squirting out into the air. Here's my evidence. Here's my evidence to say, well, I turned the valves correctly. So at the moment, without any monitoring, then they'd be pointing the finger at me saying, Andy, you turned that valve. You must have done it incorrectly because we had a burst there the very next day. So this supports the technicians in their processes. We've also done an extensive trial with Severn Trent, and they use smart valve in a slightly different way. We had 60 field users during the trial, and they really use smart valve not only to record the way valves are being operated, but also to update the information that was from their GIS system. When we imported it, they were fair to say there were a few holes in their data, and those holes were filled by the technicians out in the field. So they'd go and they'd operate a valve and they'd use smart valve, but they'd walk around the DMA and they would update the assets, adding information, saving it, taking images, adding more information. So the next time that valve visited, the information is correct. So the size of the valve, the orientation, turn to close, etc. There's images there, the location's been checked. All of that was done during the trial, and they updated 6,000 pieces of asset information during the trial. We're pleased to say during the trial there was 0 water quality complaints, so they were turning valves correctly. The valve turns weren't stirring at sediment in the DMAs, and that wasn't translated into customer complaints. And we also helped and worked on the integration plugins during the trial, so we can integrate their GIS system and their SAP system, which drives further efficiencies in their process. There are a couple of models that we implement for Smart Valve, and you can see some outline indicative prices there on the screen as well. So for the UK, the tendency of the model tends to want to buy the solution as a one-off capital expenditure purchase, and then sweat that asset over a number of years. And for us, we would be introducing updates to the app and new functionality to the app that would form part of that ongoing software contract with that particular organization. But we can also deliver it as a SaaS model. So if there's a SaaS model for lower amounts of users, or they want the safety net of having everything hosted and managed and updated all of the time, then that SaaS model is also available for clients across the globe. And we estimate the return on investment for Smart Valve is very quick. It's within 6 to 12 months in a typical water company in the UK. Anglian Water and Severn Trent did some research to say, well, valve operations can lead to between 500 and 1,000 leaks and bursts across our network in 1 year. So if we can reduce those even by 20%, then our solution pays for itself with the average cost of a major leak or burst taken into consideration. And that's not obviously including things like fines from Ofwat and water quality fines, which they also get on a regular basis. So moving on just a little bit, as a brief slide about the feature of Smart Valve and where we're going with this. So we've integrated more and more tools into Smart Valve. So we now map the client's DMA, their water network structure within the application. So they can see all the valves, they can see the type of valve, they can see the current status of the valve, whether it's open or closed or throttled. They can set up their operations directly from that DMA mapping interface in a really simple to use dynamic interface. And that means the business now gets real-time asset updates, not only the movement of the valve, but actually any other information that they're going to collect around that asset out in the field. We're starting to introduce pipe data into there as well. We're starting to consume other data sets, such as pressure data, such as leak and burst data, such as water quality incidence data, putting that into the DMA model and saying on the fly to the technician that we might need to swap around and change this a little bit in terms of how we turn this valve because of all these other factors that we've collected. So we're using the data that they've got, bringing it into the Smart Valve architecture, and that's dynamically then changing the way that that valve could be turned based on that additional information. And all this is there to eliminate the amount of water hammer, transient pressure that's introduced into the system from manual valve operations. So finally, we think this is a paradigm shift for water companies. It changes behaviors, it drives best practices, and you can set what those best practices are and you can tweak them using Smart Valve and the data we collect. And it absolutely provides less evidence of transient events and the net effects of those transient events. So we do offer free trials at the moment. We're being very successful across the piece now. So we have free trials available for any water company that wants to take us up on the offer. We can do all of our training and setup remotely because of the COVID crisis. We've been very successful in doing that over the last 6 months here in the UK. And we also provide the support and project management throughout that trial. So my details are on the screen there. So it's Andrew Talks, Director of Smart Valve. Sorry about the slight interference during the presentation, but I hope that hasn't spoiled your enjoyment of it. And thank you very much for your attention. I'll hand back over to Blanca. Thank you.
Yeah, thank you very much, Andrew. It has been fantastic. Don't worry too much about the few technical problems we had there. It was only a matter of few seconds.
No problem.
Yeah. So there are a couple of questions that I would like to ask you, and one is related to one of the last comments you have made in one of your slides about the offering of these free trials, highlighting that each trial would take only 8 weeks. And what I would be interested in, because this is the Brazil Water Week, whether you have the capability of offering these free trials also in Brazil?
Yes, absolutely. So we offer them globally. So at the moment we have trials in Australia, in New Zealand, we have some that are starting in mainland Europe, and we have the offer of one in Brazil already with one of the Brazilian utilities. So it's absolutely open, any utility in Brazil or the surrounding area, indeed, absolutely anyone. We can roll these out. We're very proficient at getting the data, setting up the users, doing the training online. Obviously, there's the language that we have to take into account, but again, we can account for that. And we can do that training and get people set up and ready to go. And it can be a small trial, and it can be more discreet, or it can be a little bit larger. The key is to find out whether our technology, please don't take us as sounding complacent, we know the technology works. It's about finding the way that you can build that into your operational processes and get it used by the technicians out in the field effectively. That's the core bit of the trial that we'd like to work with them on. So yeah, totally available.
Okay, fantastic. And during your presentation as well, you have mentioned a few times that the Smart Valve can integrate with some of the core systems that many of the utilities will use, like GIS. Is there any other core systems that also the Smart Valve can integrate with?
Yeah, so we built Smart Valve from the ground up as not being another piece of software that a water company has to buy. They already have quite a lot, let's face it. So our key is the app, so the app on the phone. That's our real core IP here. That's about the operations. Our web application is completely open. It has open APIs already built into it. We have all the data sharing readily available. So if a water company has a system which is fairly modern, even if it's not, we can build in the API through a mid layer or directly into those systems to share data. For Anglian Water, we're currently going through that process for sharing the GIS data in real time. But any platform that they have for sharing data, Smart Valve can work with. So that was always our vision. We don't want to burden them. We want to streamline.
Okay, and my final question today, I promise, no more questions. So Martin is waiting there. I will give you your space very soon. So once the operation is completed, how long does it take for Smart Valve to turn the data?
So if there's a link to the data connection, it's in seconds. It's pretty much instantaneous. In the offline world, so if there's no data connection, as long as your jobs are downloaded to your device, it will still work. It will save it on the device, and as soon as the connection becomes available, it's back up and running and sending it through to the cloud. So in real world environments and through our tests, 95 to 99% of the time, the data is viewable through the web platform in less than 10 seconds. So you have that immediate view, but everything's absolutely date and time stamped to the second. So we know when the operation had taken place. Even if the data doesn't transfer immediately, we know when that operation had taken place. And that's really important here in the UK for reporting back to Ofwat. I'm sure it's important to other utilities as well in terms of, you might be taking clients off water. How long did you do it for? We know exactly.
Okay, sure. Very important. Thank you much, Andrew.
Thank you very much.
Okay, and now we move to our last but not least speaker, Martin Guthrie. He's Senior Partner Manager at Rezatec, and please, the floor is yours. We cannot hear you, Martin. And you are unmuted. Now you're muted. No. Yeah, we could hear you very well before we started the session, so I'm sure that we'll be able to hear you very quickly. So apologies for our for this technical issue. Yeah, I'm sure it will be a matter only of a few seconds. Yeah, I think that there is some sound there. Please, if you can talk a little bit, Martin. There is sound, but I cannot understand what you are saying. No, now there is no sound. Yeah. So, yeah, no.
Martin,
So
você me
we
escuta?
have technical support, Diego Ferreira. Maybe
Sim,
he
sim.
could.
Sim, sim, vou ajudá-lo agora, tá, João?
Yes, I'll try and help him.
Thank
Okay.
you. Yes. So Marty, if you can hear me, the organizers are trying to help you to see whether the problem is on the other side. Because we know that your sound was good when you started.
Aqui no, né? Você clica na seta do lado
You
do
click
ícone
on the arrow right next to the microphone, please. And then you need to direct it to your headset, to your microphone.
Yeah.
Okay. Is it going towards your microphone but still not working?
Não.
No.
Agora sim. Ok, agora ligou, conectou.
Now it's turned on. Yes, it's connected now.
Ok.
Okay.
Yeah, but I still don't hear.
Talk?
Não.
Please speak, Martin.
Apareceu? Não.
No.
Você precisa mudar a
You have to change right here at the bottom on the language. You have to put into English. Is it? Is it into English? Okay. You go to audio settings.
Hello.
Aqui, ok.
Yes. Now we can hear you.
We could hear you, Martin. Speak again, please.
Não.
No,
Nós
we
te
lost you
ouvimos
again.
por um momento.
We could hear you for a second. You press some button or something, and right after that, we could no longer hear you.
Quer tentar entrar e sair da sala?
You're gonna try disconnect, logging out, and then logging in again.
Yeah. Okay.
Maybe that'll work. Okay.
Yeah.
Blanca, cortei o áudio, tá?
that.
Okay, thank you.
3, 2, 1.
Noah.
Okay, so my apologies.
Please, yes, if you can please upload your presentation, Martin.
Yes, I'm doing this now.
Okay, thank you.
This should work, hopefully. Can you see it now?
Yes.
Okay, good. So my apologies for the slight hiccup. Seems to have been fixed. So my presentation is about using satellites to predict the risk of network pipeline failure. My name is Martin Guthrie. I'm Senior Partner Manager at Rezatec. A little bit of background about Rezatec. So we are a geospatial data analytics company. We provide analysis on things that you see on the ground, or indeed under the ground in some cases like this, on a subscription basis. We are based in the UK, but we deal with customers globally in the US, in Canada, in Mexico, in South America, various European countries, India, Australia, and the Philippines, I think, is most of the main ones. We are about 50 people, about half of whom are PhD data scientists or Earth observation experts. And we've been around for about 8 years, based near Oxford in England. And we have one partner already in Brazil, Isol Lamon, and we are talking to other companies. Okay, a little bit about what we do. We work in various sectors. First, these are the pictures on the right-hand side of this slide. The first picture being a water leak. Obviously, I will talk about that more in the next slides. But we also provide services looking at water quality, of water that flows into catchment areas, forestry analysis, agriculture, dam monitoring technologies, and a number of other things. And on the left-hand side of the slide here, it talks about the processes that we go through in order to generate these business insights. So first of all, we acquire data. First thing to say is we don't own any satellites. They are expensive to design, make, launch, maintain, everything basically. Instead, we use, wherever possible, open source data. So both NASA and the European Space Agency, for example, have satellites where they provide data for free. It's not the best or the highest resolution data, but of course that price point is very attractive to many customers. Having said that, we're agnostic as to the data source. It doesn't have to be satellite data. We can work with drone data, aerial photography data, LiDAR, whatever is appropriate. Our IP, if you want, lies in what we do with the data. Typically that involves using AI techniques and technologies, so machine learning algorithms and pattern recognition type software. From that, we would generally aim to derive the analytics, business insights, or whatever they are that are appropriate to the sector and customers we are working for, and present results back to them using secure online portals, so secure browser windows, essentially. Obviously, there are many different applications, as I just described, but what I'll talk about just now is our approach to pipeline risk analysis. So in terms of this, what are we trying to do? Primarily, we are trying to help companies reduce the cost of identifying non-revenue water, so water loss and leaks, either reactively and help them identify where those leaks are occurring in their network, or proactively by assessing the risk over the entire network and directing them to where the pipes are likely to leak in the future so that they can be maintained or replaced or whatever before they actually leak. And typically the results we would expect to be able to provide, we'd expect to be able to provide or find 70% of the leaks in any given water network in the top 30% of the network. So we are focusing people's ability to be able to find leaks or where leaks will occur. How do we do that? So we take a number of data sets, what we call global data, in the sense that it is available generally to anybody. We include in that satellite data, two types of satellite data, one being radar satellite data, synthetic aperture radar as it's called, That allows us to see very small amounts of ground movement of the order of a millimeter or sometimes less in any given direction. Also optical satellite. This is multispectral optical analysis, but it allows us to focus on the near infrared, infrared, and far infrared bands, which allow you to see moisture on the surface of the ground and in vegetation. In addition to that, we'll take other global data sets, for example, weather, the topography of the ground, the geology of the rock underneath the ground, all of those sort of things. Also, we'd try to get local data information that's specific to the network itself that we're looking at. And those are usually pipeline attributes. So information about the material that's used in the network pipes, the age of those pipes, their depth in the soil, the diameter of them, the water pressure, if known, and a few other things. And the reason we're gathering all this data is because we can basically associate all the characteristics against each different type of a leak that have occurred in the past. One thing I should mention is that the data set that we use from the satellites has been recorded since the satellites were launched, and they started launching these ones in 2015. So we've got the ability to look back in time up to 4 or 5 years at any point of the surface of the Earth, including all the cities and areas that have pipeline networks in them. And what this means is that we can look at the data from the past in order to train the AI or machine learning algorithms to give you results on a going forward basis. We can also do retrospective analyses to prove the technology. And typically in that situation, what we would say to a water company is, okay, if you can give us 3 years worth of data about your network, the material, the age, the depth, diameter, and so forth that I just described. And also in that 3-year period, give us the first 2 years worth of information about where leaks have occurred in the past. We then do this training process using those 2 years worth of leak data to associate all the different characteristics with them. And then are able to generate a likelihood of failure analysis for that final year. Of course, the results from this are historic in the sense that that period has already happened. It's already, time has passed. So you're then able to do a direct comparison or correlation between the results that were generated and what you know to have happened, usually it's the previous year, in your network. And therefore you can see whether or not the technology works for you without having to wait for significant length of time to pass. Let me show you some example screenshots, if I can get this to work, of a network that we worked with. This was a water company based in a place called Kingston in Ontario in Canada. And the company was called Utilities Kingston. And this is just a map of their fairly small city network. And I'll demonstrate some of the things we did. First of all, they gave us information about historic incidents where the leaks had occurred previously. And we then generated this likelihood of failure map over the entire network. And as you can see, we color code it typically. So red, amber, blue, essentially for the risk of failure in all the different parts of the network. You can drill down on it by clicking on different areas on the map. And it brings up various pieces of information about the length, the age, diameter, and so forth, as well as a likelihood of failure score, which in this case was out of 1 as a maximum. So this particular piece that I clicked on that was red comes up with a score of 0.98, almost 1, very high risk of failure. We also are showing something called consequence of failure, which I will talk about a little bit more in a second. But if I click on a yellow or amber piece here, you see the likelihood of failure score is lower, 0.62 out of 1. And similarly, if I click on a blue piece, the likelihood of failure score is much lower, 0.18, so less than 0.2. So you can see the different scores that are being attributed. There are different ways of looking at this, and this particular customer was interested in seeing the highest risk zones separately, and this can be set depending upon whether they want to see the top 5%, top 2%, 1%, 0.5%, or whatever. So that's fairly easy to visualize. But the other thing I mentioned is consequence of failure. And this is really a consultative measurement depending upon what's important to the water network themselves. So for some networks, it may simply be, for example, a volume of water measurement, how much water is likely to be lost if there's a break in any given particular place. Or it may be to do with proximity to nearby sensitive assets like hospitals or schools or something similar to that. It really depends on the particular network operator themselves and what's most important to them. It could be a combination of factors, of course, as well. In this particular case, they were mostly interested in volume of water, so we simply looked at a fairly simple analysis in terms of the diameter of the pipe. A larger diameter pipe likely to lose more water should it burst. A number of these are shown. You can see some in red and amber. Typically anything that goes across bridges or it appears to be disappearing into the bay, it's actually crossing over to the other side, were large mains and therefore had a high consequence of failure should they have broken. But then one of the things you can do is take the likelihood of failure and multiply it by the consequence of failure to give you essentially a business criticality map. And this is, as I say, it's a case of how likely is any given pipe to break, and if it does, how bad will it be, is essentially what it's saying here. And you can think of this, if you want, as a heat map for proactive maintenance. These are the most important pipes by the network operator's own definition and their likelihood of failure. So it basically is highlighting things that are most important to them and how much at risk they are as well. So they were likely contenders for proactive maintenance, as I say. Now, this particular customer asked us to break down the analysis into other areas as well. One of the things we do are vegetation analyses, two types. We can either look at vegetation intrusion or we can look at vegetation vigor. Vegetation intrusion is where you have trees or bushes growing nearby to where the pipeline runs. And what's the risk of the roots of some of that vegetation impinging or potentially breaking the pipeline network. By the way, this applies equally well to supply water networks and also waste or sewer networks. Both work using this technology. And that's typically a problem with trees, for example. Using one of the technologies we use for forestry, we're able to determine both the size of the trees and the species of the tree. And if you know the size of the canopy of it looking down and the species of the tree, there's a correlation with how far the roots are likely to grow underground and therefore whether or not they're likely to affect the network. So that's one thing we do. We can also look at vegetation vigor, and this is particularly applicable in hot summer months where a lot of grass would typically be brown. And if there's unusual amounts of greenness in grassy areas where you would not expect it, that may be indicative of leak activity. So that's one of the things we showed them. And the other thing they were particularly interested in was the ground movement aspect of this. And there are many different ways of looking at this, but a simple way is just to highlight flags over a couple of years of where the ground has either moved up, raised up, I should say, or subsided. The raising up is known as heave, and that's what's shown as the blue pieces here. Subsidence is shown as red. And we can click on those to bring up more information. So clicking on a red piece shows you a wavy line, which is not at all unusual, by the way. You tend to get cyclic seasonal movement over time. Typically in the wet season or winter, the ground absorbs the water and expands. In the dry season or the summer, it dries out and it contracts. So you tend to get a sinusoidal type graph from that sort of response. However, even if you were to flatten out the graph that's shown here, you'll see the overall trend is down. And it's not a great deal. It's a matter of a few millimeters, as is shown here. We also talk in terms of the velocity of this movement. In other words, how fast the ground is moving. If it moves unusually fast, that can be a sign of something else going on as well. So that can be indicative. Equally, if I click on a blue piece where the ground is raising up, again, you get sort of lumps and bumps, as you would expect from the seasonality, but the overall trend is up. So this is the sort of information we are typically supplying to the water companies, and people say, okay, that's great, but where is the value? How good is this? What sort of results will you typically expect to get? So normally, what we can achieve is focusing in on the network such that in the top 10% of high-risk areas, we would expect people to be able to find 33% of the leaks, so a third of the leaks. The top 20%, it's 49, almost half of the leaks. And the top 30% of the high-risk area of the network, we would expect people to find at least 70% of the leaks. These are not best case figures. These are typical in use, and we've worked with a number of partners around the world who have confirmed this to be the case. And there's a couple of usage scenarios basically in this situation. One is as a way of assisting with IoT detection technologies. So for example, loggers, acoustic loggers, pressure loggers, or whatever they may be. Typically, we have seen customers in many countries around the world just deploy these loggers across their entire network in order to detect leaks. But the thing is, if you know the risk of the leakage, then it makes much more sense to deploy them intelligently and focus them on the high risk areas. We've seen customers save at least 30% of their costs by only deploying in high risk areas and achieving results that were as good as what they would have done if they just blanket covered their network. And that can be a very significant saving in money, many millions of dollars, pounds, euros, whatever currency you are using. Of course, the other side of this same coin is in your personnel deployment. You can use this information to route optimize where you send your teams so that they get better results, more bang for their buck, if you want to call it that, for their time. Both are money optimizing and resource optimizing techniques or capabilities. So that's my presentation. Hopefully I'm in time. My contact details are here. If anyone has any questions, I'd be happy to answer.
Yeah, Martin, great timing. Thank you very much, in spite of the few technical hiccups at the beginning. So since you have mentioned something about cost, I was wondering about how do the cost scale for large cities? Like, for example, if you have a city which is 10 times bigger than a smaller one, what is happening with the cost? Is it also 10 times higher?
No, is the short answer to your question, Blanca. Satellites, of course, are passing over the surface of the Earth all the time. They capture all of the data anyway. It doesn't matter to a satellite whether it's a small city or a large city. So the only extra costs involved are the processing of the data and storage of data, but those are not particularly high. So basically, as an area increases, the cost per area or per square kilometer decreases. It gets cheaper per square kilometer basically as we get bigger and bigger.
Okay, fantastic. And the other question is that imagine that now somebody who is listening to us would like to know what it will happen if I want to do a pilot now in Brazil or wherever they are from at the moment, because this old presentation is broadcasted. in YouTube widely. Yes, so the question is, how quickly can you start generating results and analysis? You know, how long, once you start speaking with a potential client, how long do you need to wait, for example, for this data that you need for your analysis? Is it 1 year's worth of monitoring? How long is it, and what is the information that you need?
Okay, so we can usually start generating data very quickly, almost immediately, because what we can do is look back in time, as I mentioned during the presentation, of 1, 2, 3, sometimes 4 years, and carry out an analysis of what has happened up until this point, and therefore start giving them useful data immediately. So it allows us to set a baseline, if you want, at the very beginning, or indeed to generate results looking at the previous year that will give them some confidence that the results will work for them. So this can be as a sort of a pilot or a proof of concept activity if they want, but equally if they are keen to start straight away, then we can start giving results. So to actually process the data itself takes a month or two, generally speaking, and then we can start giving immediate results.
Okay, fantastic. So these were all my questions for you, Martin. As I said, great presentation. Thank you very much. And now I would like to invite back Marcello, if he is available, to close the session. It might be that he is not available. I will pause for a couple of seconds. So if I can ask, please, all the speakers to turn the cameras on again, please. Thank you. So I see that Marcello is not online now. Maybe he has had the technical problem. We have had only a few. So I would like to thank you, all of you, for the great presentations you have provided. It is very important as well, I'm sure, for everybody who was on the other side of the screen today, that you have provided not only clear presentations, but your contact details, and also details about opportunities to collaborate, your presence in the region, and so on, which is fantastic. And there is therefore a great opportunity for engaging with utilities and any other end user in the region. I'm very happy that we have been given the opportunity to use the space here today at the Brazil Water Week, and of course honored to have you here with me today. Thank you very much to the organizers. Thank you very much to Marcello and the Interamerican Development Bank as a whole for the support they are providing to the sector, and also to us, helping to introduce innovation and technology and best practice to the sector. So with this, we conclude the session. Thank you all, and I hope that I will see you all very soon. Thank you. Have a good evening and good rest of the day. Bye for now.
Thank you.
you.